Okay. Okay, good evening, everyone, and welcome to the final examination preparation for the cloud practitioner. This is mainly for everyone that has completed the classes that we've been having. Just a quick, we are trying to condense all the material we've had all this while, but the focus here is what's essential for the exam. So you don't expect to see everything here as we're moving ahead. So for our objectives, we would look into the exam content, then which is the board, the bulk of the material lies there. We'll talk about question structure and time, then registering for the exam, yeah, online exam versus on-site exam. We'll just try to bring that almost to at the end. Now, the content outline, this is what is required when you are looking at the exam syllabus. You have the cloud concepts, you have security and compliance. Cloud concepts cover 26%, security and compliance 25%, technology 33%, and billing and pricing 16%. So you need to at least be familiar across the board there. And the passing is 70 on, yeah, 700 marks on 1,000. They try to scale it to have that amount. Um, just before I go ahead, just I noticed, okay, um, there are certain terms that we define, but I think this is one of the terms I missed, and I noticed some people at times wonder, like, what is on premises? And I just thought I'd bring this up here. Just to emphasize that when you hear of on-premises, it means software and hardware infrastructural setup deployed and running from within the confines of your organization. So you have complete control over the infrastructural setup. So when you can think, for example, a data center being operated and run by a bank, a hospital, or any business organization. That is, and it's restricted only to the members of the bank, hospital organization. So that's what you always tend to refer to as on-premises. So that is a data center located at an organization or at a hospital, for example. So let's look at what we need to deal with in domain one. So domain one is cloud concepts. It expects that you should understand what the cloud is, what is AWS, key benefits of AWS cloud, AWS infrastructure, and ways to access or interact with AWS cloud. And I know these are certain poor areas that look a bit obvious, but if you are not careful, it will be painful. Let's say you're in the exam and then we are looking at a very easy question and you know very well that this should be easy and you can't get it. So it's important to make sure that these key concepts, you really master them well, because there's a difference when we're talking about them. Definition of cloud computing: on-demand delivery of IT resources, that is network, server, storage, applications, and services over the internet with pay-as-you-go pricing. So the key thing there is um, when you do the cloud practitioner, you should be able to define what cloud computing is. And the key point is on-demand delivery of IT resources. And then after that, it should be available over the internet on a pay-as-you-go pricing model. Those are the key things: on-demand delivery of IT resources over the internet on a pay-as-you-go pricing model. The major characteristics of cloud computing is on-demand, self-service, broadband network access, and resource pooling. I think I have more of them listed here, characteristics of cloud computing. So you have on-demand self-service. What does that mean? On-demand self-service. Because we have noticed in some of the questions, they will try to see if you understand what each of those characteristics mean. So if when you say on-demand self-service, it's automatically provisioning resources without the need for human interaction. Think of EC2 instance. When you click your EC2 instance, you don't need to write to AWS that you need an EC2 instance. once you have an account with them, it comes automatically on demand. You're asking for it. It just then it has to just be there when you need it. Any service you want in AWS, you get that on demand and it's automatic. Point two, right here is broadband network access. So it's very crucial. Without the internet, you can't talk of the cloud. So you access the cloud services over the network, and you should be able to use both thin or thick devices. Thin here are simple devices like mobile phones or tablets, and then thick devices could be laptops or workstations. So your laptop, or you may have a workstation that you can use to access that. Then the other one is resource pooling. When you are accessing the cloud, you should be able to save um, providers resources. So AWS should be able to have their resources in such a way that they can serve multiple consumers and assign those resources dynamically. So when for this goes at the AWS end, before they can be a cloud provider, they should be able to uh, have many people sign into their network, and they should be able to assign the resources to them in a dynamic manner. There should be rapid elasticity, which is the capabilities are provisioned and released in some cases automatically. So rapid elasticity here is the scaling in and scaling out. So if it happens that someone is using some particular resources and needs a certain increase, that should happen without, that you can think of auto scaling when we'll come to that. That should happen automatically. So that's rapid elasticity. And if he's using so many resources and wants to reduce that, they should be able to scale in without, automatically as well. Then it's a measured service. So resource usage can be monitored, controlled, and reported in a transparent way. So it should be very clear when, as a customer, you want to look at your bill. It should be very transparent, both for the customer and the provider. You can know that if you are being billed this amount, it should reflect that this is actually what you consumed. In some cases, if you don't know, then that's something you then have to fix, that maybe you are consuming some resources without your knowledge. So these are the key characteristics of cloud computing, and you should be able to pick out what rapid elasticity means, what resource pooling, broad network access, what all those things stands for. Um, the next thing is, let's look at cloud computing deployment models, right? So when you know now that those are the characteristics for any organization that wants to call itself a provider, they have to meet those characteristics, then definitely they're a provider. But now there are different deployment models. We have the private, which is this type of model in which an organization enterprise uses proprietary architecture and runs cloud services within its own data center. And this is always referred to as on-premises or on-prem, which is what I discussed earlier. So you have everything running on your own data center. Red Hat offers some of that. IBM and OpenStack are examples of top vendors offering solutions that can actually help any organization deploy a private cloud. Then a public cloud is the one that we all know, which is a third-party provider makes compute resources available to the general public over the internet. So this is where AWS, Google Cloud Platform, and Microsoft Azure, the top three, come into play. Then the hybrid model is a mix of on-premises and private architecture. So when you combine the public and private cloud providers, what you end up with is what is called hybrid model. We'll talk about how that connection is being done when we start talking on the networking area. Then now, yeah, we've talked about the type of models. There are three types of cloud computing, and these are the ones that are essential for the practitioner level, because I know that there are at times you may see other names like function as a service, database as a service. But on the syllabus for cloud practitioner, these are the ones that you should really, really be familiar with. So you have the infrastructure as a service, IaaS, and it typically provides access to networking features, computers, and data storage. So one thing you should notice with IaaS is that you are having access to networking features. You can access the underlying operating system and the storage. You can reach out and touch, let's say, the network devices. That is like the network cards. You can configure them. And that's what makes it similar to existing IT resources, the traditional IT ones that we know of. Let's say if you were to go to a data center, it will be something similar like that. So when we look at the graphs, that will be easy to understand. But an example is EC2. So you always reach out and you can touch the underlying storage of EC2, the operating system, and you can configure the network card of your EC2. Then we have platform as a service, which is a platform as a service removes the need for you to manage underlying infrastructure. So here, you no longer have access to the underlying infrastructure. You focus on the deployment and management of your applications. And this is where Elastic Beanstalk come into play. That's an example of platform as a service. You have software as a service, which is just in most cases, is the end user applications, such as web-based email. You can have Gmail, Google Apps, and Dropbox. So I think that should do for platform access for the type of cloud computing models. And you see here how it looks like. So when you talk of on-premises, right? On-premises is, if you see the blue color here is showing the area that you are in charge of. So when you talk of on-premises, which is more of like the private cloud, you are in charge of everything: the networking, the storage, servers, virtualization, and even the physical infrastructure. You're in charge of everything here. Now, but when you move now to the cloud computing, which starts with IaaS, PaaS, and SaaS, what you realize is the highest you can get to is the operating system here, which here is referring to, that's the guest operating system. Remember, we said that EC2 is an example of an infrastructure as a service, and you can actually access the operating system of your EC2. But the other parts, which are virtualization, the servers, storage, and networking, those are areas that is handled at this other level, is handled by your provider. So this is the only areas you're able to access. And for platform as a service, these are the areas that the provider is managing, and you just come to data and applications. You remember for AWS Beanstalk, when we'll discuss that, it will come more into like why it belongs to PaaS, because it's just code that you put and you run. And yeah, and so this is the area that is just for that's managed by the provider. When you move to software as an application, the whole line is managed by the provider. You just get the end product, like Gmail. You never bother how the computers that are in charge of Gmail. You never bother. You just use it as it is, and you just write your email, you send them, and most of the time they manage everything. The providers manage everything. So this should be a very key area that you should really distinguish and be able to pick out examples here. And it should be an area you should be uh, well covered with. And now this is also the benefits of cloud computing. And we remember again in our revision, we have seen cases where they will look into some of these uh, areas and try to see if you understand what's really happening. For example, what do you mean when you talk of agility? Increase speed and agility. You can quickly spin up resources as you need them. So that's one of the benefits of cloud computing. So make sure you understand when we talk of agility, what that reflects to. Two, this is a point we have touched so many times, trade capital expenses for variable expenses. So capital expenses here is referring to things like data centers and physical servers. So you no longer have to be in charge of this. And then point three, stop spending money running and maintaining data centers. Yeah, so when you are on cloud computing, you most of the time you are focused on your customers and you don't bother on the heavy lifting of their racking, stacking, and powering servers. So that's what it means by you stop spending money running and maintaining data centers. Then benefits from massive economies of scale. Um, so lower variable expenses that you can get on your own. So what happens here is usage from hundreds of thousands of customers when they are when you have like for the providers, when they have many users that are able to access the resources they have, they can offer very low pricing because they are, then what happens? You are the what then lower variable expenses that you can get on your own. So when this compared to when you are running a data center, you always have resources that are standing and idling, and imagine if you were offering them for other customers, that would be very cheap. So I'm just thinking of you think of what happens like AWS when they have so much resources and they can offer that at a very to many customers, and they are able to offer that at a so they can reduce cost because their resources are constantly being used. But when you buy resources to be running on your own, it's you always have ideal resources. So there's a massive economics of scale when you're thinking of cloud computing. Then stop guessing capacity. Yeah. So you just provision what you need and you can increase or decrease depending on your needs. You go global in minutes. So applications can be deployed here in different regions just at the comfort of your office. You can deploy in America, deploy in Asia, and deploy in Europe just with a click of, just, say say right from the comfort of your office anywhere. That's something you couldn't have achieved if you were thinking of doing that on your data center. But here I try to give the definition of capital expenditure because we talk about capex. So that is the when building data centers, organization invest in upfront costs for building servers and supporting equipment. And this type of expense to attend a fixed asset is referred to as a capitalized expenditure or capex. Then operating expenditure, which is OPEX, that's the regular day-to-day expenses of a business. So now when you have, even if you buy servers and you set up everything, there is still the ongoing maintenance, trying to ensure that, paying of electricity bills and all of that. That's operational expenditure, operating expenditure, which is something that you don't really bother about when you move into the cloud. Um, Now let's look at global infrastructure. This is everyone should have this on the tip of their fingers. Um, One, we have regions. Regions belong to a specific geographic region made up of two or more availability zones. Take note of that. It's always two or more availability zones. There's no region that has one zone, maximum of two. But now let's look at availability zones. They are made up of one or more. So take note, availability zones is one or more discrete data centers. So an availability zone can have just one data center, that's possible. But if they have more than two, if they have more than one, then there's a low latency communication between the availability zones, and they are separated by a meaningful distance, many kilometers from any other EZ. So if you have more than two of them, they'll be separated. Then you have edge locations. That is a site that CloudFront uses to cache copies for your content for faster delivery to users at any location. It allows to save uh, from locations closest to users. Okay, I have to delete that. And it's used for global content delivery. So edge locations, they are used for content, global content delivery, and it's used more, yeah, for caching copies of, yeah, of data that has to be delivered. When we talk about CloudFront, we'll mention edge locations again. So these are the key, when you talk of AWS global infrastructure, these are the key things you should know. There are questions that are always trying to ask you, um, which of the following statements are true, let's say in regards to availability zones, or which of the following statements are true in regards to the global infrastructure, and they could talk about regions are made up of maybe one availability zones, regions are made up of two or more availability zones, then they can come to availability zones are made up of two or more data centers, they try to twist them around, and you have to then make sure that you have the correct version as defined here, at least on AWS. So edge locations, services at edge locations include Amazon Route 53 uses actually resides at the edge locations. CloudFront, as we said, for caching, AWS Shield and AWS WAF. These are very key components that sits at the edge. One that I've not listed here is Lambda Edge. Yeah, but I don't really, I know that we came across that uh, last time, but I don't really, but these are the very key ones that are common when we are talking about the practitioner level. So make sure that you understand that these are they belong at the edge locations. Now let's just look briefly, interacting with AWS services. This is very key. I mean, I think we've come across that a lot in the revision, and you have to be able to distinguish which one is which. There are three different types to interact with the with services from AWS. You have the management console, and this is a graphical user interface. This is the one where you log in with your username and password. That's the one that almost everyone is aware of. If you created an AWS account and you log into the account on the web browser using your username and password, that is actually the AWS Management Console. Another way that you can access AWS is using the command line, and this is done through a terminal. You require access keys that are associated to a specific IMI user. We'll talk about the IMI user later, and it offers possibility to do automation than clicking around. So there is a possibility to actually automate when you are using the command line to deploy resources. But the key thing you should note with the AWS command line is that for you to be able to access AWS services, using the command line, you need access keys. And these access keys are always associated to an IAM user. We have, in our revision, we have mentioned that access keys are made up of an access key and a secret key. So make sure that you are very familiar with this. And the other one that we talked about is the software development kits. That's AWS SDKs. So when we talk of, we've always mentioned SDK, but that's actually stands for software development kits. And this is a programmatic way of interacting with AWS account or services. And you also require access keys, and it offers more possibility for programmability. So you can do more programming when you are using the SDKs. That's something that I don't we've used, but the command line and the console are two that we've demonstrated. So this is for those who always say they have more of a photographic memory. You can easily capture this if you have AWS services, then you can either use the command line with terminal and you require access keys, or you use the AWS SDK, which is be more of using code and access keys. And if you are using the console, then you need your username and password. This is, I think most of you will agree that we've seen questions that are dealing with this. So make sure you capture that. Um, I will pause here for a moment and just ask if there are any questions or comments or just observations. So